The next topic that we need to discuss is intersection and union of sets. To help us understand that, I've just drawn, I've given you a very specific example to take a look at. Let's say I've got these two sets. I've got set A, and set A has elements 1, 3, 5, 7. Set B has elements 3, 7, 9, 11. Okay, the easiest way to probably explain what intersection and union means is just by showing you an example. I have the definition in the notes, but you probably didn't really understand what it said. So intersection means that you're looking for things that you're looking for where the two sets overlap or where they come together. What do you see that occurs in both sets? If you take a moment and look at it, you might say that they're intersection. What goes into the intersection? Well, I can put set 3 appears, 3 appears in set A and in set B, so I can include 3. And the element 7 appears in both sets. So 3 and 7 would be the intersection of set A and B. There is notation that goes along with this as well. Intersection is denoted with like an upside down horseshoe. All right, so we can say A intersect B equals set with elements 3, 7. Okay. Union is a little bit different. Union means you basically take everything. It all goes together. The symbol for union looks like a U. So this is the symbol for union. This is the union symbol. So we can say that A union B, and again, union just combines it all. Union takes everything. So I'm going to list everything that I see up here, like the total, all of it. Now, if something is repeated, I don't have to write it twice. So for my union, I need to say 1, 3, 5, 7. All right, that's everything from set A. And then in set B, I've already got 3, I've already got 7. But I also need to include 9 and 11. Okay, so union takes it all, everything. Sometimes students have a little bit of difficulty understanding how to differentiate between intersection and union. I'm going to give you kind of a strange little example, but it might help you understand it. If you think about union, what's another type of union that you might think of? An example would be a marriage. In a marriage, everything that the husband has, everything that the wife has, is all combined and brought into the union of the couple. Intersection, if you're just intersecting one another, if a couple is just intersecting one another, they're only sharing a little bit. They're not sharing very much. So, and also the symbols, that looks like an N and that looks like a U. So hopefully that'll help you to keep it straight a little bit. All right, so let's go on to the next example in the notes. So for example 3, we are asked to find each of the following sets, and we're asked to write our answers in interval notation. I have drawn number lines to help us through this. So these are the original sets A, B, C, and they are given to us in interval notation. So I'm going to graph set A on this first graph. So this is set A. I'm going to graph set B here, and I'm going to graph set C here. So set A is the interval from 1 to 5, and it does not include the endpoints. So I need to shade from 1 to 5 on set A. There's my graph for set A. Set B is interval from 3 to 7. I need to include the 3, but not the 7. Square bracket at 3, shade all the way up to 7. Put the round parentheses on 7. Set C is everything from 6 to infinity, and 6 is not included. So parentheses at 6, shade everything to the right, positive infinity. All right. So we can use our graphs to help us find the sets that we're asked to locate. In part A, we're asked to find set A union B. So again, here's set A, here is set B. Union is telling me to take it all. So everything from set A, everything from set B is going to go into my answer. So can you see where that would be? Pause the video for a moment and think about it, and then we'll talk about it together. Okay, so if you combine, or if you take everything from set A and everything from set B and put it all into a union, you're going to have everything beginning at 1, going all the way out to 7. So you would say that that's the interval from 1 to 7. That includes everything from here to here. So A union B is interval notation, parentheses 1, comma 7. Part B, A intersect B. All right, again, pause it, think about it for a second. So A intersect B means that you only take the areas where sets A and B overlap, where they touch. And they only touch from here to here, so from 3 to 5. All right? For our interval notation, our symbols will match the symbols that we are seeing here. So starting from 3 with a square bracket, the two sets intersect all the way up until we get to 5 with the round parentheses. So our interval is square bracket 3, comma 5 parentheses. All right, I'll let you go ahead and pause and continue with part C and D, and then we'll talk about those. So for part C, you're asked to find A union C. So you need set A here and set C here, all combined into one set. All right, now you'll notice there's a gap. From 5 to 6, there's a gap. All right, so you probably didn't know how to write that. We're going to say everything from 1 to 5, in parentheses, union, use the union symbol, and then you can include the interval from 6 to infinity. Okay, so we've got interval 1 to 5 union, interval 6 to infinity. One thing you have to be really careful about is that sometimes interval notation can look a lot like an ordered pair. For example, if you just looked at this, you would probably read that as x equals 1 and y equals 7, which is a totally different topic. So just be really careful that you don't confuse that. This is the interval from 1 to 7. In part C, we've got the interval from 1 to 5, union interval from 6 to infinity. And then for part D, when we do A intersects C, intersection means that we're looking for where they overlap. All right, well, set A only goes up to 5, and then set C begins at 6, so they never overlap. They never touch at all. So A intersects C is going to be the empty set. For empty set, you could write set notation with nothing inside, or you could do a circle with a slash through it like that, either way. Okay, so you should have read in your notes just before you get to example 4 that a compound inequality simply means that you're going to be working with more than one inequality at the time, and they're going to be connected with a word and or. The word and will imply that you need to use intersection. The word or means that you need to use the union of the two sets. So looking at example 4, part A, we need to solve the inequality, the compound inequality 2x minus 3 greater than 5 and 4 minus x less than or equal to 3. So we are going to solve each one individually first. So with the first piece, let's add 3 to both sides. 2x is greater than 8. Divide by 2. So we get x is greater than 4. And in the second inequality, we still want to keep x on the left side. So let's subtract 4 on both sides first. And we get negative x less than or equal to negative 1. So we need to divide both sides of this by negative 1. So that's going to give you, or you could think of this as multiplying both sides by negative 1. Either way, you should have positive x is greater than or equal to positive 1. So make sure you remember to flip your inequality since you're multiplying or dividing by a negative. So these are our two pieces. We've got x is greater than 4 and x is greater than or equal to 1. How are we going to give our final answer in integral notation? We need to look at the graph first. So x greater than 4, again, notice I'm only putting numbers on here that only the numbers that you really need and just a few around those numbers. X greater than 4. Because this has got two individual pieces to it, I am going to hold off and put the final answer on the graph until I can see what each piece looks like. So if I look at x greater than 4, I would shade everything to the right of 4. So I'm not going to put it directly on the number line yet. I'm just going to come above the number line and shade everything greater than 4. You can do an open circle or you can do a round parentheses symbol. So that's x greater than 4 there. And now I need to do x greater than or equal to 1. So find 1. I want to shade everything greater than. And I'm going to use either a closed circle or a square bracket. And this time I'm going to come below the graph. So that's x greater than or equal to 1. The reason I did not put them on the graph yet is because I still need to take into account what operation I need to use. And it's telling me to do the intersection. So if I take the intersection of these two individual pieces, where does my final answer need to fall? Think about that for a moment. Pause the video. Okay, because and means intersection, you only take where the two graphs touch or where they're coming together. So only from 4 out to positive infinity is where the two graphs meet. And you're going to use the same symbol that you have here. You'll use a round parenthesis symbol and shade everything greater than 4. So this is my final answer on the number line itself. I'm going to erase these little pieces that help me arrive at my answer. I have to give my answer in integral notation. So it would be, integral notation will be parentheses 4, comma, infinity, parentheses. Example 4, part B, we need to solve and express our answer in integral notation. 4 minus 3x less than negative 2, or 3 times x minus 2 in close parentheses less than or equal to negative 6. So we'll go ahead and solve each for x. Subtract 4 on both sides, you'll have negative 3x is less than negative 6. Divide by negative 3, and because you're dividing by negative, you have to make sure you flip your inequality symbol. So you'll have x greater than positive 2. Over here you've got 3x minus 6 less than or equal to negative 6. Let's add 6 to both sides. So you've got 3x is less than or equal to 0, and divide both sides by 3. X is less than or equal to 0. Okay, and now we need to see what this looks like on our number line. So now we'll graph the two individual pieces, x greater than 2. I'm going to put it above my graph. So I'm going to do the round parentheses and shade everything greater than 2, like this. You could also do the open circle. X greater than or equal to 0, I need to shade everything smaller than 0, including 0 itself. So I'm doing a square bracket and shading everything to the left. Now, again, make sure that you pay attention to what operation you need to use. The word or is telling me to take the union of the two sets. Union, again, means you take all of it into the union. So we're going to include this piece and we're going to include this piece, and they both go into our final answer. So we can graph everything from negative infinity up to 0, shade it very clearly on the graph, and everything from 2 with the parentheses to positive infinity. You can erase the little pieces that you use to arrive at your final graph.
Hi guys,
And
this
then
is
we need
Miss
to give our
Lewis.
answer
I'm
in integral
goofed
notation.
up in that video. That should say parentheses negative infinity to 0, square bracket, union, parentheses 2 to positive infinity. So on the left side, the graph begins with negative infinity, not with negative 3. So parentheses negative infinity to 0, square bracket, union, parentheses 2 to positive infinity. Okay, back to the video.
Example 4, part C, we're asked to solve this. This is called a three-part inequality, or sometimes we call it a sandwich inequality. -4 less than or equal to 3x minus 1 less than 5. So this is really the same thing as an and statement, but the and statement can be written all in one inequality with 3 parts. To solve this, we're going to, let me find something. We're going to basically do the same steps that we would do with any inequality. It's just that we have 3 pieces to handle. So instead of having 2 sides of your inequality, you have 3. If we just cover part of this up and look at this as 3x minus 1 less than 5, whatever first step that you would typically start with here, we're going to do the same thing. You would probably start by adding 1 to both sides. We just add it to all 3 sides. So we're going to do plus 1, and do a plus 1 back here. So -4 plus 1 gives me -3. All right, these ones cancel out in the middle, and then I'm dividing 1 gives me 6. All right, again, cover this piece up, and you can see that you would want to divide everything by 3 to get the x by itself. Your goal is to get x by itself in the middle. So divide all 3 sides by 3. Okay. Now, we get -3 over 3 gives me -1. I did not flip the inequality symbol because I divided by a positive 3. So you're getting -1 is less than or equal to x less than 6 divided by 3 is 2. So this is the inequality. How do we express this in integral notation? Let's talk about what the graph of this is going to look like. So my inequality is indicating that x is between the values -1 and +2. The graph will reflect the same thing. I need to shade everything between -1 and +2. All right. The symbol here tells me what to put at the -1. All right. So if you were to read this, if you were to break this apart, it would say x is greater than or equal to -1. So you need to use the closed circle or the square bracket at the -1. Over here, this is x is less than 2, so you can use the open circle or the round parentheses at 2. So this is the graph from -1 to 2. Integral notation can be read directly from the graph. So our integral notation is going to be square bracket. Well, I'll let you think about it for a second. So your integral notation will be square bracket, -1, comma, 2 parentheses. And that is our answer, integral notation.